There we go. I'll try that again. Hi, I'm Josh Keegan, and welcome to the Space Down Under Live. I just realised I had myself muted. Oh, good grief. Anyway, it's live, so there you go. So I managed to have some technical issues last time this went live, and I'm now doing it again. And I've had an issue with mute already. So this is going really, really well. So unfortunately, the last time we went through this live stream, it encountered a few technical issues. I managed to sort out those technical issues, and now we're able to go through with this live stream without too many problems. Let's hope the mute button was the one and only thing that I had wrong with this one. All right, in this episode of the live stream, I will be joined by Souktik Bhattacherjee, who is a space architect, a computational designer, an international architectural journalist, no less, architect, and also an urban designer. So just make sure that you grab a cup of coffee, or at least your favorite beverage. I've got mine, and let's get started. Welcome, Souktik. Great to have you live on the Space Down Under. For everybody who is having a look at this sort of stuff, Souktik and I actually met virtually at the International Space University Adelaide Conference, which ran over 2 days from the 3rd to the 4th of February in 2023. The International Space University Conference brought together speakers from around the world, such as Souktik, and also included the head of the Australian Space Agency, Enrico Palmero. So, Souktik, can you please just tell everybody a little bit about yourself and how you became interested in space architecture?
Hello, everyone. Thank you for inviting me here. I'm very excited to be here as we met in the International Space University conference, Adelaide conference, and then we had planned for this. So I'm Souktik Bhattacherjee. I have done my bachelor's from Jadavpur University, Kolkata on architecture, and then currently I am doing my master's in architecture on urban design. In the meantime, while my architectural study, I had several coincidences to go into space architecture. The first most important step was the joining the space station design workshop that was by the University of Stuttgart, and we worked with lots of architects and other engineers, even astronauts, who gave guidance to build space architecture in a more practical way. And I was fortunate enough to be a part of a company called Akash Space Studio, which is one of the first space architectural firm in Canada and India as well. So, and in the meantime, I also did my thesis and dissertation on space architectural topics like the origami, how deployable origami structure works in space environment, what are their advantages. So that's all how I came into space architecture, and
Wow.
here we are.
Wow, and now you're here, and we're going live right across Australia, and we're also going live right around the world. So, thank you very much for that introduction. That was a very good background on exactly how you managed to get to this particular point in time, and thank you very much for joining me in this Space Down Under live stream. So, just for everybody who is following along at home, remember that the question and answer section is open for the duration of the live stream. So, feel free to not only ask questions of my guest here, but also introduce yourself and get to know some of the other people who may actually be joining us in the chat live. So, Souktik, what exactly is space architecture?
Okay. So looking at the space architecture, it's a two term. One is space and another is architecture. So architecture is definitely the building. Like when you are building something, when you are doing anything for humans to live, that's architecture. And when we are doing it for the space environment, that is when people are going to space environment, like in the what will say, like the orbits. That is the low Earth orbit. That is something that is called International Space Station is there, which is a live example of space architecture. Another houses on the moon, houses on Mars, and the the endless. There are possibilities are really endless. Even the crew, the rocket, which is carrying the what is it? Carrying the crew to the space
Yeah.
environment is even an example of space architecture. So that is we call as or transfer habitats. So uh, even when we see that the environment is inhostile, like there is a hostile environment outside, and inside the habitat is the only habitable environment, we tend to go through the term called space architecture. So in looking from this perspective, when we design like space architecture, not only is about space, but it is also about the environments which is like extreme environments, like let's say Antarctic or Sahara desert, or where the environment which is not really habitable, like under the water is even a part of space architecture. So these things whole comes up together in the form of space architecture. And looking into the space architecture, it is not just about architecture, it is like there are several other disciplines that are as well involved, like psychology is involved, human factor engineering is there, and say like whichever field you might like, mathematics is definitely in one of the part, physics we should always maintain because nothing without physics really works out, anthropometry, and there are several other fields which are together comes up in the space architectural domain. So that's the part of the domain of space architecture.
Right. So okay, that was a lot, and that's a lot lot to consider. So, my next question would be about what would be involved with determining important features for living on the moon or Mars. You mentioned a couple of different things there in terms of space architecture, the environment, and all that sort of stuff, as compared to the Sahara Desert. And those types of environments. So, what is involved in determining what are the most important features or the important features for living on, say, the moon or Mars in this instance?
Yes. So whenever we are planning on to go to moon or Mars environment, we need to plan out several things, that where we are going, how much time we are spending there, and so that is called the duration of the mission, even how many crews are going, and what are the mission objectives. So these all factors, whenever you prepare all these requirements, you get a certain guideline to design your habitat. So these are the few of the factors, and definitely the challenges that we are going to face. For example, when we are going to a orbital level structure, so there is no planetary surface, right? There is no surface, we are always in a orbit, constant orbit, we are revolving around the earth. So the main challenge become is that how the habitat is stable. We use gyroscopes and other in like materials, like equipments to maintain the habitat, like which
Mm-hmm.
direction it is going, how propulsion works in that environment. And even now let's go to moon or Mars, there are planetary habitats but the distance is really far. So what are the equipments you are taking, how many, like what is the logistics you have, and even what are the technology that you are using. For example, if we are going for a very long mission, definitely we will go for something like 3D construction, like 3D printing construction
Yep.
technology, we will go for it. But if we are going something like 3 to 4 weeks, or not 3 to 4 weeks, like 3 to 4 days, what we
Yep.
did in Apollo missions, we can see that there are human landers that have Eagle lander is there. So those are something like a prefabricated structure which had been landed there, and we did a work for very small time.
Mm-hmm.
So these are the total encompasses all the things that we need to consider while we are going from Earth to space environment, and definitely doing space architecture.
Right. Wow. That is a lot. Yeah. I mean, certainly the duration of the mission and the environment you're actually going to is with a couple of the important factors, and also protecting human life as well while you're getting there. So, in the opening introduction, you also mentioned about origami. Sorry, I'll never get this right. Origami habitats that are able to be used. So, what exactly is an origami habitat?
Okay, so when we are going from Earth to any planetary surface or doing space architecture, for there are different stages involved. Like when we are going for a very short period of time, and when we are going for a really long period of time, and in the intermediate there are need for some deployable structures, like we can see that some any habitat which can be deployed from, let's say, from the Earth to the like when you're going from Earth to the Mars, there are some deployment that happens. Okay,
Mm-hmm.
So that is we call the class 2 habitats, that is the inflatables or origami.
Oh,
So
right. Yep.
inflatables is more like a balloon, which is like you just push in some air and the volume expands, and that becomes the habitable volume. But in case of origami, what happens is that we must have all played with origami when we are very young, like from paper folding, right? So paper folding technology can also be used like a panels. We use something called elastic panels, and we can use those patterns. Like you can see in the screen that there were several patterns, like vertical axis below origami pattern, crestling pattern is there, central axis below pattern is there. So these are the types of pattern which we can use to like give the human a habitable volume.
Yep.
So my research which we did on my undergraduate dissertation was about that how much volume did increase from the highest to the lowest, and which pattern did really fits the best. And definitely from that we got some benefits that which definitely support the like the class 2 habitats, like we can use technically. And there are several applications which we can do on the earth. So definitely when we are doing for space environment, when we are developing something for space environment, it does not like have to be absolutely for space. It have several impacts on our earth environment as well. So we can see the applications in the military camps, quarantine house. Like we needed rapid development of the habitats, right? So those spaces we can use the origami structures. So that's how like the research of origami is all about. And we can see several origami habitats coming up in the near future maybe. So
Oh, okay. Yeah. Just a second.
that's
I've
all.
got yeah. I've got a few of those images that are coming up in just a moment, as well. So when you were actually talking about origami habitats and things like that, so and you're talking about habitats on different planets, how do you propose to combat things like radiation while maintaining a breathable environment? Do you have a potential solution for that?
Yeah, definitely. So whenever we are going to space, we have to keep in mind that the environment have to be habitable. Like at no cost we cannot like keep humans in an inhostile environment. So that is the must thing. So there are several challenges, like not only radiation, but there are like not only radiation and oxygen part.
Mm.
There are challenges like, let's say, meteoroids are there. Micrometeoroids are always bombarding into these structures. So those are the very big challenge. Then there are other challenges as well. There is hard vacuum, like there is no atmosphere technically on moon and technically in space. So we have to maintain the pressure as well inside the habitat. So now what we do is that we subcategorize these challenges. Like whenever we are dealing with radiation, we are dealing mostly with the structures, like what structure are we using, so what are the materials we are using. So those material have some kind of like give the people a kind of radiation shielding.
Hmm.
So that shielding reduces the amount of radiation that goes into the human, and to give them like whatever that is recommended, like radiation dose. There are several radiation dose that are being fixed by the NASA to for the humans to go through. So that is how like the radiation is shielded through the materials. So some of the materials that we generally use in the structure is called Kevlar, high density polyethylene. um, so these are some of the materials that we use. Now when we are thinking of that, okay, now we are done with the radiation, but what about the oxygen part? Like how do
Yeah.
we generate oxygen, or how do we maintain the cycle, like how do we make the things habitable? So there is a special subsystem which is called ECLSS, or environmental control and life support system.
Yep.
So what happens in this subsystem is that there are several parts of it. That is, one is the oxygen recovery, another is the like water recovery. So there is a water cycle that is going on, another is the air
Hmm.
cycle that is going on. Like the so here what happens is whatever we breathe in, whatever we take in, it gives out some kind of byproducts, right? So those byproducts are again being recovered by the system to us. And in the meantime we also have to take in concern some of the things, like we are also developing carbon dioxide, like we are giving out carbon dioxide whenever we are taking in oxygen, right? So that carbon dioxide should not go beyond the amount, like the amount which is not habitable. So those are the all the things that are being looked after by the life support system. So that's how the environment is made habitable inside the habitat. With the pressure, definitely the pressure have to be maintained with the airlock. There is an airlock that is being fit in the wherever human goes from the habitable environment to the space environment, let's say for extravehicular activity, EVA. So there should be some kind of airlock that should be present. So that maintains the pressure inside the habitat. So these systems together, another thermal control system is also there. So these are the, like, it maintains the heat, how much heat it is being gained, how much heat it is being produced. Radiators are involved in this thermal control system. So these huge factors together comes up in the space architecture domain to make the habitat habitable in the space environment.
Well, yeah, it needs to be habitable in the end. And, I had this conversation just the other day with someone who was the Deputy Premier of South Australia, actually, Susan Close. And she and the point we were making there is that nothing can be thrown away, especially when you're out exploring space, because even our waste product is
Yes.
actually something
Yes.
useful, including our waste for the growth of fruits and vegetables and all that sort of stuff. So speaking of waste and the growth of fruits and vegetables and things like that, um, so is that considered when you're actually designing a habitat for exploration of the moon and Mars? So is that something that you actively take into consideration?
Yes, so that is a very good question. Whenever we are dealing with that, are we considering the growth of foods and vegetables while we are going to Mars or Moon? So it totally depends on how much duration we are giving. So if we see the Apollo mission, like we had gone for few days, few weeks. So in that few weeks of time, we cannot grow, like there is no sufficient time that is given to the astronauts or the space environment to grow food. So in the short duration time, it is not feasible to grow or like take some saplings there and grow and utilize it as a food. But whenever we are going for a long term mission, like let's say 6 months or 7 months, we cannot really take all the foods from the earth. So that is why in the current, if you see the researches that is going on in the International Space Station, there has been lettuce and cabbage, and there are several other plants foods are being generated through the processes, like there are other processes that are involved through the
Yep.
machines. So those processes are like giving the technical result of how we can grow food on space, and those can be applied when we are going for a very long duration mission. Like we give some dedicated area for that, how much volume. So at first we calculate that how much volume we can give to dedicate space for the growth of food, and how much product we will get. So these systems get fits into the life cycle of the, whenever you're designing the whole mission architecture of it. So
Mm-hmm.
these systems get fit into those fit into our lifestyle, and we get that okay, this much we are consuming, this much is our surplus, and this much we can take risk. So these are all factors that comes into consideration while we are doing for a very long duration. But in short duration, again I will say that okay, we don't really need to consider the, we will grow food in this. But
Yeah.
yes,
Okay. Well,
now see,
Well, short-term
yeah,
duration missions, you don't actually need to grow food. It
yeah,
would mainly be for
yes,
the longer-term
yes,
duration
yes.
mission. So, yeah, just going back to the origami habitats. Yeah, here's one of a video of from SAGA. Space
Saga.
SAGA, Space Architects, of what an
Yes,
origami habitat
yes,
would
yes,
look like when it goes to expand.
yes.
So it actually manages to increase in volume. So and that one is
Mm.
quite significant. Just going back to that to explain it in a little bit more detail. What are the advantages, Sutik, of actually having an origami habitat versus a just an ordinary like the International Space Station? You were saying before that
Yes,
there was the
yes.
three different classes
Mm.
habitat.
Yes.
So what's the difference between all three of them? Which one would be better for space exploration? Do you think?
Okay, so that's a very nice one. So looking into that, what is the, which one is the better? Definitely depends on that how much time we are spending. Like what is the duration of the mission? So if we are going for a long duration mission, we must go for something like a 3D printing, or we are planning on for a long term settlement on Moon.
Yep.
So we are going for 3D printing. So like I think like in the end of by the end of the Artemis mission, we will see that there are some 3D printing habitat on moon that are being coming up. Or when you are going for something like a very short, we will go for something like prefabricated, right? And
Right.
when we're going for intermediate stage, we will go for inflatables or something like origami. Now whatever we see, whenever we see the like the short duration mission, we have to build everything on the earth and take it to space, and that becomes the habitable volume. So let's say when you are building the international space station, what happened was that the space shuttle mission was used to build the space station, so in
Hmm.
space assembly occurred. So what happened is that we designed the module, we designed the entire, let's say, destiny module on earth, made the habitable volume, put it in the space shuttle, and space shuttle took it into the space environment and then fitted with the extra other parts, and it becomes the part of the habitat. So this is the how the space station is made. So what we can see that the volume remains constant. Now what is the disadvantage of this is that it requires huge amount of money. Why money, I'll say? Because the weight that is being carried, or the volume that is being carried from earth to the space environment is huge.
Yep.
But when we are going for inflatables or origami, we can literally collapse it. Like we can literally fold it in a very small part, and then whenever, so what happens is the volume get reduced, so the weight of the like the net weight get reduced, and whenever we are putting that thing on the space environment and expanding with, we can see that okay, so the total weight gets reduced, right?
Yep.
So hence the money also get reduced, and that is the main advantage. Now the other advantage, if you see that, okay, now why you are not using like inflatables, like why
Yeah, that's
origami is
my
slightly
question. That's my
better, or
question to you. Why won't what's the advantage of an origami? Sorry to stop you in the mid
hmm,
sentence. I do apologize, but because I've seen the inflatable module that was attached to the International Space Station. I believe it's still
hmm,
there. So
hmm,
what's the specific advantages of using an
yes.
origami structure over an inflatable?
Yes, yes. Okay, so there is a very beautiful history that I will come into.
Yeah, sure.
So in the very initial stage of the ISS development, like much before when ISS was planned, there were plan of making something like a torus-shaped habitat, which is entirely inflatable.
Yep.
So before that, but it was tested on site on the NASA. So
Yep.
they found that okay, micrometeoroids is the big challenge for the inflatable structure. Whenever a micrometeoroid hits a structure, it punctures it, and it is like a mess. Okay, so that is a very old story. So that's why like the NASA plane changed their plan, and gradually the International Space Station came up. But now when we have such a range of material
Hmm.
which have the capability to build something like an inflatable structure, there was a company, there is a company called beam Bigelow Aerospace Company,
Yes.
who proposed a transhab. Like you can see one of the slides, there was a picture of transhab. So it's a basically a cylinder just blows away. So so there was a technology readiness level required for every technology to go in space. So they are in the very initial, like I think 6 to 7 technology readiness is currently there for the beam. What
Yep.
they did is that they took a very small package of the inflatable structure and put it in the International Space Station, and they see that they monitor that how it is functioning, like is the environment habitable, what are the challenges that are being faced. But the main challenge again came up is the how to mitigate the micrometeoroids. So that is the
Right.
most biggest challenge that is inflatable. But yeah, when like if you see the new constructions that are being made by the, let's say, Axiom Space, or uh, I don't really remember the names of the private space companies
Yep.
who are actually trying to put something like a inflatable structure in space environment and build the new space station. So that becomes a part of. Now where origami plays the most important part is, see, you can see that there are several panels that are involved, like there are
Yep.
many mechanical joints and panels. So panels are the rigid body structure, like it is bit elastic, it has some kind of elasticity, but it is not really elastic to the point that it is the most what is it, like it is the like it is like vulnerable to micrometeoroids.
Yep.
So we can, and also the another part is the maintenance. So whenever we are telling of the, like whenever thinking of the maintaining a origami part, we can literally put like take out the habitable, like the
The
take out
panel.
some pressure.
Yeah.
We can just place the, like whatever the requirement is there. And the another advantage is that we can even 3D print those parts in space and
Ah,
fix it
gotcha.
on the habitat. So that becomes a like a major advantage of taking origami structure. But definitely origami structure habitats have the lower TRL, like technology readiness level, than the inflatable structures.
Yeah, gotcha.
So so maybe we will not see origami structure in a like a bit hurry. If we see in a next 10 decades, definitely we can see some 3D printing technology.
Yep.
But in next 20 to 30 years, definitely we will see several origami structures that are being carried out. And maybe it have a huge potential whenever we're going for a like a intermediate stage. Like, okay, we don't really need something like a very like permanent settlement on moon, but okay, we will just go have some visit, chill out in the moon, and then come back. So that
Yeah.
becomes a
Well,
part
see,
of it.
the other advantages too is that with the origami space habitat, we're dealing with, I believe we're dealing with things that are more known. So like we can just replace a part and whatever else and print it out.
Yeah.
Whereas the inflatable habitat is, you rightly say rightly so, is if it's pierced, then
Yes.
that's the whole habitat gone. But the main problem with the beam space habitat at the moment, which is on the International Space Station, is that company no longer exists. The Bigelow Aerospace is gone. It went bankrupt, I believed, or it's been put on pause or something like that. So,
Yeah, they had several space stations on the line. Like they
yeah,
have
they
something
did.
called Nautilus and
But
several other space stations they were planning, like space hotel. They even some built some prototype of space hotels. See, we have our
yeah,
space hotels on Earth.
well, yeah. Well, and that's the thing is that, but that's the line they were trying to take. But the other ones
Mm,
that you were mentioning as well, the other companies, Amazon has got their orbital reef. Axiom
mm.
Space is building extension to the
Yes,
International
yes, yes,
Space
yes,
Station.
yes.
And there was one more I've forgotten. But anyway, there's a couple of questions that have come in as well. So I'll take this moment while I'm just chatting to you here to ask before we get into the artificial intelligence part of the discussion is. Jim Cleland, of course. Good on you, Jim. G'day. How's it going? Thanks very much for joining us here on the live stream, mate. Question for both yourself and my guest: what inspired your interest in space travel and technology? And for him, it was the end of the Apollo program and Skylab. So yeah, Souktik, what inspired your interest in space travel and technology from your point of view?
Mm. Okay, so when I was very small, I used to look into the books which had a very beautiful graphics of space. Like, okay, this is space habitat. Like, there are lots of they're deep into the space. So I was totally involved in that. Okay, vastness of space, and I was like a kid who is like, okay, like let's understand the physics part of it. So I was more into the physics part of that, how space really was, space environment
Yep.
it is. And gradually with those interests I got into some, like I got into architectural stream. So when I came into architecture, I feel okay, we cannot do anything for space, but on my head there was a constant hit, okay, do it something for space, something's for space, like there was a knock.
Yep.
So whenever so I got a chance to actually participate in a competition called Marception, which is a something by Ball Zero. So
Oh.
I participated there. I just came into the then I came into the terms called space architecture. Okay, I came into that. Okay, space architecture is really there, and that what excited me. Okay, what since it is there, let's go for it. And when I started studying, so I really realized that there is a lot of aerospace engineering happening in the space architectural part as well.
Yep.
So grasping the architecture with aerospace engineering and doing a mixing of both these two, and then a breakthrough came when I joined the space station design workshop. There I realized, okay, there is a huge team that is being involved to build a single habitat, and how things really work.
Yep.
So that is the most big, like a breakdown point when I was like, okay, I can do something in space. And that's what inspired me. And also, like, I also joined the firm called Dhaka Space Studio. It is led by space architect Astha Kacha. She
Yep.
really inspired me, like how to go, like how space works, and she gave a mentorship to me as well. So like I was there for about 1.5 years there.
Yep.
And yeah.
Yeah.
So
Look, I think everybody on the live stream already knows my interest in space. Because my interest in space went, I was very, very young when the first, without showing my age, I was very, very young when the first space shuttle launched.
yes,
And so
yes.
for me, that was a case of being a wide-eyed kid, seeing what effectively was a aircraft strapped to a rocket that flew to space. Being very, very, very young, I didn't quite understand, but it was the coolest thing I'd ever seen. So, I'd gotten into the space industry that way,
Yes,
and
yes,
I learned
yes,
all about
yes.
the space shuttle. And when the International Space Station was being built, I'm watching it, all that sort of stuff, really like closely. And so the reason why I'm here and doing the Space Down Under is because I came to the realization after many years that I got tired of looking at traditional media, and I get my little 2 minutes or half a minute or 10 seconds of images of other planets, and then basically they go on to another news story because it's not as interesting.
Hmm.
And then I found out that
Yes.
Australia was going to have our very own space agency, and I just went, okay, I think now's the time to actually do something about this. And I just love the fact that I can talk to people such as yourself, from all over the world and from here in Australia, just to talk about the Australian space industry, and also to talk about the wider space industry that's out there. So yeah, and I've always wanted to be a part of the space industry, and now I'm part of the Australian space industry by having a YouTube channel. I guess that's the way I come into it. But yeah, there you go. Jim also has a second question as well. He's got another one which says, if you had the chance to travel to the surface of the moon or indeed Mars and occupy one of the future origami habitats, would you take it either as part of a crew or a solitary explorer? That's actually a really interesting question there, Jim.
Sorry, like, can you just
Yeah, no, you're right. So
reframe it?
would you if you had to go if you had to go to the moon or Mars and you were taking an origami habitat, would you
Yeah.
like to be part of a crew, or would you like to be a solo explorer? Go by yourself. What do you think?
That's a that's a very interesting question actually. So
It
whatever
is. It's a
technology we
very
currently
interesting
have
question.
and currently
I just put up the wrong
that
display. So yeah,
okay,
using
we
one of
have
these
to go with.
origami habitats that's on screen currently, would you like to go and do it yourself? That's the actual question.
No, no, definitely we will take some crew as well, because you see, whenever we are going for a space mission, we cannot do anything solo. Like, there is a team involved.
Yeah, that's
Teamwork
true.
is the most important thing. So anything doing solo is a mess. Like, it would be a mess because you cannot be everyone. Like, I cannot like really go into a rocket, drive my rocket myself to the Mars and again doing. But yeah, definitely if there is a AI friend of mine who is going to do all the tasks for me and I will be there for chilling, I will definitely go solo.
That's a really good segue into the next question, or a really good lead into the next question. So thanks very much, Jim, for those questions there. That was very, very interesting. And in terms of artificial intelligence, how is that changing space architecture? What are the impacts that it's having?
Okay, now see, looking into the artificial intelligence. So let me be very clear. Artificial intelligence is a more like a buzzword for now, because everyone is using artificial intelligence.
Yeah,
Like,
that's
we
true.
really don't know. Like, like whenever we seeing into YouTube, there is artificial intelligence. Whenever we doing into Instagram, it's their artificial intelligence. So every part and aspect, like if you see, like 20 to 30% of our daily like work is done with artificial intelligence. So now going into detail, what artificial intelligence really is. First is, it is a tool. So like we will not go beyond the basics. Like the basics of the space architecture would be same, whatever we are dealing with the like artificial intelligence or not. So artificial intelligence is a important tool that we use for to improve the workflow or to improve the prediction of structures in the space architecture. Now where we really use, like being in architectural field, the like the limited, the scope for artificial intelligence limited, and it requires huge amount of data to deal with, which is not really there. And there are other stuffs as well that are involved. Now first of all is that since we have enhanced the power of artificial intelligence, the computational power, so definitely it have changed the workflow. Now, see, let me give a small analogy.
Sure.
Like on more than 20 to 30 years before, we had a floppy disk, like some kind of card used to be there, and
Yep.
it has to be like 20 MB or 30 MB. It was with this size, this
Yes.
big,
I
20 to
remember
30
those.
MB.
You don't have to explain it to me. Sorry.
now
Yes, I'm
now
old.
now recently I came across with a chip. Like a chip is just like I can
Yep.
show it like this much,
Hmm.
and it can have like a 1 TB of storage. 1 TB, that is like
Yep.
like how many times, like it's a millions of times than what we had. So computation have evolved, like the computational power have evolved from 0 to trillions of times.
Yep.
Now how we are harnessing that thing becomes the challenge. Now where we can really use, one is that, like let's say, predictive repairment. Like there is a habitat, and
Hmm.
we can really predict which part of the habitat can go down in a short period of time. So that becomes a predictive maintenance. Another is the swarm intelligence that is coming up. So there is a swarm of robotics, we can control those things and build something like a habitat. So those are the few applications of the artificial intelligence, though the basics will be same for a long period of time for now, unless we can see a major change in the workflow. But still now with chat gpt and mid journey ai and other chat, we can see that how we design homes have changed. Let's say, like for example, if you see in the architectural stream, we can see that there used to be like we used to design, and then we have to make some views, and then we have to show the clients. Now some of the firms, what they do is directly go into mid journey, give the like whatever the inputs they want, like this is the style I want, this is the thing I want, this is the sketch I want, this is the whatever I want, and in few seconds mid journey give the results, so that they directly show to the client, and the reverse engineering starts happening. So you could
Right.
see that there is a major change in the workflow. So
Yeah.
now definitely this is not really possible in space architecture. Like there are several challenges, because there are constraints are much more.
Mm.
But definitely in future perspective, we can see something like an integrated system. Let's say we are giving, like, even there is I found there is a software, I really don't remember the name what it was. So what it did was, we have to give that how many crews it want, how many hours or days we want to stay, what are the necessary equipments we want to give. We have to give those inputs,
Yep.
and that ai used to do is that calculate what is the oxygen demand, what is the carbon dioxide oxygen demand, and everything,
Wow.
like how, what is the water cycle, what is the food production, everything that ai used to do and give a result. So that result gave us the idea that is that mission possible or not possible. So
Yep.
that is a huge thing we are solving with ai. So that's how ai have impacted space
Yeah.
architecture.
Okay. So yeah, it's actually a tool for to crunch the numbers and the amount of data that needs to come into it to actually get the results you're
Yes.
looking for. To then to reverse engineer what you're looking for. Sorry, on screen while you were talking, I put up M Mars. I apologise for putting that in the middle. I thought that we related to what you were talking about. So could we just
No.
spend a couple of minutes just explaining what M Mars is, please? It says it's a metaverse microgravity analog research station, and
Yeah.
I apologise. I've completely forgotten what this is about.
Okay, so MMARS is something like an analog, but in metaverse. So we are utilizing the idea of metaverse, that is the digital environment, in a something like a pod. Like we can use those things inside a pod where the humans, like whoever the crew is, can experience the space environment through metaverse and the hard, like there are like, but if we break down metaverse into two parts, one is the visual, like whatever we are seeing, another is the physical, whatever we experiencing. Now both becomes the most important part. So whatever we are visualizing becomes the part of the, like what we are seeing, what we are doing work in the metaverse environment. And what we are experiencing is the microgravity. So the design target was to design something like an environment which will act as an analog, analog for the space environment. So that so the astronauts can train or do whatever they are going to experience in space, they will just do it on the earth, and then they will get ready for their future missions. So that's how
Right.
they can go, it is give a ability to train them through metaverse technology.
Wow. Wow, that's amazing. That's absolutely amazing. Yeah, I never even thought of it like that. That you can use the metaverse to go through the tests and all that sort of stuff. So in regard to the habitats, and regard to all the space habitats, we saw the origami habitat that was being constructed on Earth. Are there any other habitats that are currently currently under development to test designs and prove out theories? Is there anything else apart from the origami habitat, which we saw the graphic for before?
Yeah, yeah. There are several habitats that are analogs. Like
Yep.
those are like the keep simulation to the real Earth environment. One of them is there is a Uta. There is a habitat in Uta. I just forgetting the what's the name of the habitat.
Yep, you're right.
Um, okay, there is another habitat called Habitat Marte. Lunaris is there, and so there are several analog habitats that are being spread across the globe, which help the astronauts to train themselves, give them certain kind of certification, and also give students or researchers a chance to do research on Earth through the experience of space, right? So there are like if you say, okay, if we are not into space, how can we do something like an analog? Like it would be like a gameplay, right? But it is not. Whenever like there are several researches that involve psychological advantages, like so when the crew are staying in a confined environment for a very long time, the researchers can study their psychology. Even the researchers can study the samples from the earth, because there are several sites, whatever I say saying that Uta one. So Uta have some kind of like the Martian soil is there, like there are some soils that are available on Mars as well. So they can study those through EVAs and do the perform the other simulations. In fact, they also even did something like a space suit, how astronauts will take the space suit on, how much time they take to put on the space suit, to do the EVA on site, and get back home. So this gives them a clear guideline. So
Yeah.
what we are currently doing is that we are refining the process, right? So more refined we get, the more better our solutions or more better our future looks. So
Right.
those are
So
the
better
things that
how it better informs your architecture and your designs and all that sort of stuff. Because yeah, you want to sort that stuff out on Earth well before you put anything into space or you put anything onto
yeah,
another planet. Absolutely agree. So that actually gives me a really clear indication of exactly why the Mars Society it
yeah,
does
yeah.
it as
Mars
well.
Society have one.
Yeah, they have one. The Mars
Mars
Society,
Society
yeah,
have
the
one.
Mars Society Australia has one that goes to the Mars Society
Mm,
in the US. So yeah, now
yes.
that now gives me a really good explanation
Yes, even that
because
habitat I was
yeah,
talking about, it was by Mars Society. I really forgot the name. What the name was?
yeah, absolutely fantastic. All right. Well, look, this has actually brought us to the end of the live stream. So, look, Sutik, I just wanted to say thank you very much for joining me on the Space Down Under Live. It's been an absolute pleasure. It's been wonderful having you here and joining us. And unfortunately, there's been no other questions that have come through, but I've thoroughly enjoyed that. And there's a couple of bits in there that just really explain to me and obviously the audience, anybody who's watching, exactly what this will mean in terms of AI, being used as a tool for crunching numbers and putting all the facts and figures together, which will then influence design, obviously, of design of the architecture and the habitats. And I'm quite keen and looking forward to seeing the origami habitat go to orbit at some point. That would be awesome. But yes,
Yes.
look, thank you very much
Yeah.
for joining me here on the Space Down Under. I do
Thank
appreciate
you.
your time. So, and again, well, I must apologise for the last time, for the last live stream,
No
how it didn't
worries.
quite work out. Again, yeah,
No
and for
worries.
the mute on this one as well. So yeah, I thank you very much for your time. So. I
Thank
know. I
you.
do appreciate all that everything you've done, and for taking the time once again to join me live. All right, everyone. And so, if you just to let everyone know, if you like this live stream, and you know what to do, especially if you're looking forward to seeing the results of my trip to Adelaide, where I actually interviewed quite a few different people, which includes the Deputy Premier of South Australia, Susan Close, Kelly Yeo, the founder of Blue Dwarf Space, and also Frank Gallagher from SAGA Astronautics, where he actually showed me around the Responsive Space Operations Centre. All right, guys. So thank you very much for joining me on the space, for watching the Space Down Under live. And remember, as always, stay hyphenated.